Case study: failure analysis of a helical compression spring. Abstract: helical compression spring function as an energy absorbing machine element. They absorb vibration and protect structure from damage. They act as shock absorber in a vehicle suspension system and thus help in giving comfortable ride by mitigating the transfer of vibration from road irregularities to the vehicle and the rider in turn. It has been observed that most of the compression coil spring fracture at the transition position from the bearing coil to the first active coil in service. While the nominal stress here should always be much less than that at the inside coil position of a fully active coil. This paper aims at analysis of the reason for failure of a helical compression spring. The prime focus is on fatigue failure because this is the mode of failure for most of helical compression spring in dynamic loading condition. Keywords: raw material defect, surface imperfection, improper heat treatment, corrosion, and decarburization. Introduction: most of the vehicles have helical compression spring as one of the primary elastic member in their suspension system. They act as an energy absorbing machine element. The prime aim of a vehicle suspension system is to connect the wheel to the body. A helical compression spring being an important part of the vehicle suspension system, absorb energy and smooth out shock that are received by the wheel from road irregularities. Thus, it helps in giving comfortable ride by mitigating the transfer of vibration from the road irregularities to the vehicle body and rider in turn. Fatigue failure of the suspension spring often resulting in a variety of ways owing to the dynamic surface loading condition. The reason for fatigue failure of suspension spring are raw material defects, surface imperfection, improper heat treatment, corrosion, surface condition, and decarburization. It's the combined act of some of the above mentioned reasons or all of them that lead to fatigue failure. The inner surface of an active coil of the helical spring is the position of maximum stress. Raw material defects, surface imperfection, improper heat treatment, corrosion, surface condition, and decarburization act as stress riser and lead to failure of spring, usually at the inner surface of an active coil of the helical spring. Common reason for spring failure. Some of the common reasons that lead to failure of helical compression spring in SUR are listed below. There are the prime factors that lead to failure of spring under dynamic loading condition. Raw material defect, surface imperfection, improper heat treatment, corrosion, surface condition, decarburization. Pot model with imperfection left and its FAA model right. FAA model showing high stress level then nominal at point of imperfection. EA model showing corrosion. FAA model showing stress concentration at the place of corrosion. FAA model showing inclusion and stress concentration due to the inclusion. Conclusion: it is the clear from above analysis that raw material defects, surface imperfection, improper heat treatment, corrosion, surface condition, and decarburization act as stress riser and lead to failure of spring, usually at the inner surface of an active coil of the helical spring. So it is imperative that a helical spring is designed with a great care. Raw material selection for spring manufacturing is the first step where a designer must look for presence of raw material defects as they play an important role in fatigue failure of spring. It is equally important to look for manufacturing blunders like imperfection in coil surface that may develop during coil of spring and improper heat treatment that may lead to decarburization.